Okay, we're talking about a functions test and the top 5 things you must know if you expect to do very well. So this is going to be applicable to those of you that are pretty much at, let's say, the algebra, high school algebra level, whether that be algebra 1 or algebra 2, intermediate algebra, let's say you're in college or college algebra, maybe even pre-calculus, any of those type of courses where you're studying functions, this is definitely going to be applicable to. And even middle school math, maybe like pre-algebra or 8th grade math. So if you're studying functions, you definitely want to pay attention. Now, I'm going to be covering 5 things. You want to stick around for all 5 things. This is not going to be a complete full lesson on all 5 things. That's just too much to pack into one video. But I will highlight and point out some things that you certainly need to be focused in on. Make sure you understand. I do have a lot of other videos on functions on my channel, so if you like my teaching style, would encourage you to subscribe. Check out a lot of my playlists on algebra. You'll find other videos on functions. And if you're looking for something more comprehensive, you might want to check out my full courses. I'll leave the link in the description of this video for all my various courses. So I really get into functions in my algebra class, algebra 2, etc. But with that being said, let's get right to it. And the first thing you need to know is some real basic definitions and terms. So you need to know what a function is. Okay, so what is a function? Okay, so I'm just going to be kind of, I'm not going to give you like a formal set of notes here. So we're just going to kind of review and highlight. Again, you should have a set of notes, but this is at least going to trigger things that you need to focus on. Okay, so you need to know what a function is. So a function is a certain type of relation, okay? It's a certain type of relation, and a relation is, let's take a look at it this way. Oftentimes we look at a function as a function machine, okay? So for example, for every x input, you're going to get one and only one y output. So this is a function. Okay, so for example, let's say I have f of x is equal to 2x plus 1. If you're confused, just stick with me, okay? This will clear up here in a second. So if I have a function, by definition, when I plug a number into my function, an input value, I'm going to get one and only one, exactly one output value. That's my y, okay? So this is my output. Now, along with this understanding, that is the definition of a function. Now, in mathematics, let's kind of draw another little thing over here. You could have something called a relation. Okay? And you can have various x inputs, and you can get various y outputs for one input. So for example, let's say my x was equal to 2, and I threw it into my relation machine. I could get one output value, or I can get another output value. Okay, so that is a relation. You can think of relations as points on the xy plane. So that's the basic definition of what a relation is. So a function is a specific type of relation. So a function is a relation. So all functions are relations, but all relations are not functions. Okay, remember, functions are very specific. Okay, for every input, there's only one and only one output value. Okay, now the input values is we refer to those as the domain. So the values that we can plug into our function are allowed to go into a function. We refer to those as the set of numbers called the domain, and then the output is called the range. Okay, so you need to definitely know what the domain and range is. And I can continue on and on this topic because there's a lot to know just in even this first category, but I'm just kind of highlighting some things that you should be able to understand what I'm talking about. If you don't understand what I'm getting at here, even with the definition of terms, that's an indication you need to go back and review further. Okay, so let's see here. What other things that we could talk about in terms of definitions and terms? Well, one of the ways we can test for a function is using the vertical line test. All right, so let's say I have a graph. If I draw a line, a vertical line, anywhere through this graph, it only intersects the graph one time, okay? So if you have a graph and I draw a vertical line anywhere along this graph and it crosses only one time, then this graph is a representation of a function, okay? That's really important. You do definitely need to know the vertical line test. Let's take a look at a situation where something doesn't pass the vertical line test. Let's say I have a graph like this, and I wanted to say, hey, is this a graph of a function? So you would use the vertical line test, and you'd say, oh, look, it crosses through twice, so therefore it fails the vertical line test. Because the vertical line test, you can have, the vertical line can pass through only one time. Okay, so here it passes through twice, so it could pass through 2, 3 times. If it's more than one, it fails. So this graph is not a function, it's a graph of a relation. Okay, so definitely things you need to know. Also, you need to be able to understand how we construct functions. Let me just do a real basic one here. So oftentimes we use a mapping diagram. So we have x and y. Now, before going any further here, you notice how I drew the arrow from x to y. So the x is the input value. We often call this the independent variable, and the y is the output value. So this is referred to as a dependent variable, and this is the independent variable. Okay. So let's say here 1, 2, 3, 4, 5. Okay. Let's say I gave you a mapping diagram like so. I say, okay, 1 maps to 4, 2 maps to 5, and 3 maps to 5. So the question might be, does this represent a function? So what you're looking for, does every x go to 1 and 1 and only 1 y? So what do you think in this diagram here? Is every x going to 1 and only 1 y? Well, yes, it is. Students get confused right here. Okay, they're like, oh no, 2 is going to 5 and 3 is going to 5, so this fails as a function. No, this is okay because 2 is going to 5 and only 5. 3 is going to 5 and only 5. It's okay. You can have an input value go to one output value, but you can be different numbers can still have the same output value, and you're okay. As long as 3 didn't go to, let's say, 4 and 5, that would fail. Okay. So these numbers here, 1, 4, would be the ordered pair 1, 4 on a graph. Okay. The x and y's are like the xy on the xy coordinate plane. So big part, the first thing you need to know in terms of definition of terms, is everything I covered here, and especially how to determine whether something is in fact a function. Lastly, really in a real basic way, you need to know how to evaluate a function. So let's say I have this function right here, and I said find, here, let me erase this, find f of negative 5. You need to know what that means. Okay, evaluate this function for this value. That means plug in the negative 5 where the x is at and then simplify. Okay, so you have to go with your order of operations. This is negative 10 plus 1, so that's negative 9. So f of negative 5 is equal to negative 9. So we're going to move on to our second one. Again, you can already see there's a lot to cover. Functions is a huge topic in mathematics. Generally takes a couple, 2, 3 weeks to cover all the material here. So how do I know this? Well, I taught these courses from middle school through high school and college for several years. So I know what I'm talking about as a math teacher. So trust me, you want to pay attention to what I'm saying. Okay, let's move on to our second thing that you must know, and that's function operations. So function operations would be something like this. Let's say I have a particular function f of x equals 2x plus 1, and I have another function g of x equals 3x, let's say. Okay, so you might be asked to find f of x plus g of x. This is actually pretty simple. Okay, all we do here is simply f of x is 2x plus 1, in this example, and then we're going to add it to the g of x function, which is 3x. Okay, and then we just simplify. So this would be 5x plus 1. So f of x plus g of x is equal to 5x plus 1. Another example would be, let's say, find negative 3 of f of x. So again, we're just going to multiply negative 3 times the f of x function, which is 2x plus 1, and simplify. So this is going to be negative 6x minus 3. So various examples you can multiply. I'm not going to do it here just for the interest of time. You'll be asked to find f of x times g of x, okay? And then lastly, you're going to be asked to find composite functions, which is a certain type of function operation. This really confuses students. So guaranteed you're going to see function operations, you're going to see a composite function questions on your test. Again, I have a lot of videos on this on my channel, so you might want to check this out, but I'll show you a quick example here, okay? Remember how we evaluate a function? If I plug in a number right here, and then like that previous example I just did of f of negative 5, well, in this case, I'm not plugging in a number, I'm plugging in this function. I want to find what f of g of x is. Now the g of x function is 3x, so I'm going to be plugging in the 3x right here. So therefore, this x in this function, the f function, is going to be replaced with the value of the g of x function, which is 3x. So f of g of x will be 2 times this 2 here times x. But x is what I'm plugging in, the g of x function. It's the 3x. Okay, plus 1 to finish this out. So then we got 6x plus 1 is f of g of x. So composite functions, definitely need to know. All right, let's move on. Function inverse. You have to know the function inverse. You can see our fourth one down here. I'll talk about that in a second. Okay, so function inverse. The inverse of a function, the notation looks like this. F of negative 1x. That's very common notation. So a couple key concepts. Let's just, before we get into it, let's look at a couple things here. So remember that if I asked you if this is a function, you would take your vertical line, right? And you'd say, yes, this is a function because it passes the vertical line test. Okay, so we could see clearly it passes. However, sometimes we want to determine if a function, okay, so this is a function. We're not going to call something a function unless it passes a vertical line test. Now, some functions have what we call function inverse. So to determine whether a function has an inverse, you use another test called the HLT, horizontal line test. It works the same way as a vertical line test. So you can see a horizontal line will only cross through this graph one time. So if you have a function and it passes the horizontal line test, then it's what we call a 1-to-1 function, meaning that it does in fact have an inverse. So not all functions have inverses, okay? So just be aware of that. Now, what is an inverse function? Let me show you a basic example, and you need to know this as well. Let's go back to our mapping diagram. X, Y. Okay, let's say 1, 2, 3, 4, 5, 6. So 1 maps to 4, 2 maps to 5, 3 maps to 6. So this is the point 1, 4, the point 2, 5, if I saw this graphically, and the point 3, 6, okay? This is the what? Domain. Remember the X input values, and this is the range, all right? Now, if this is a function, let's call this a function, okay, and it does pass, right? Every x goes to 1 and only 1 y. The inverse of this function is a function that essentially reverses, here, let me draw this, it reverses the range and domain. So here I still have the domain, and here I have the range, right? This is our x, and it's going, let me do it this way, and it goes to the y's. Yeah, let me actually write it like so. domain, and range. Okay, so the inverse of this function up here, the inverse of it basically flips this thing around. Okay, so the inverse has the range of the function. So let's write this down: 4, 5, 6, and the domain inputs, the outputs are the domain of the original. Okay, so the range, basically the domain and range get flipped. Okay, so 4 is going to go to 1, 5 will go to 2, and 6 goes to 3. Okay, and we see this graphically. Another important concept on inverse functions is if you graph a function in inverse, they're going to be symmetric along the y equals x line of symmetry, okay, or axis, excuse me. So, for example, if I have a graph like this is my function, and this could be like my inverse function. They're going to be symmetric along this line. So this could be my function, and this could be my inverse function, for example. Now, again, I'm doing a lot of things here. I haven't even told you how to find the inverse. So if you're like completely lost at this point, I would say like, okay, finish watching this video, get a good framework of what you need to understand, and then go back and, brush up on all these topics. It's a lot of material. Functions is a big topic, and you learn it throughout the years of studying mathematics. Okay, for example, if you're studying Algebra 1, you're going to see this again in Algebra 2, you're going to see it again in the college algebra, pre-calculus, etc. So you might like, oh my goodness, this is too much. Well, yes, it is, but you build up this knowledge over time. But don't minimize that. Don't think like, oh, I don't need to know this. You absolutely need to know this if you're, studying mathematics, because it's just going to come up again and again and again. Okay, so this is basically what a function inverse does. Or if I have a function, an inverse function is going to switch the domain and range, and we could see it graphically this way. Okay, let me erase all this stuff. Let's talk practically how we actually find the inverse. Okay. All right, so let's say I have this function, f of x equals 2x plus 1. One of the things you need to know is that the notation f of x is also equal to the variable y. Okay, so y is equal to 2x plus 1. So that what you do in order to find an inverse function is you switch the x and y. So I'm going to replace the x. Okay, we're here. This is the y. I'm going to replace it with x, and then where the x was, I'm going to put the y in. Just flip-flopping those guys. You see what I just did? So once I've done that, I'm going to solve for y. So I'm going to write it this way: 2y plus 1 is equal to x. Just reverse, just flipping the sides here. I can do that. It's not a problem in algebra. But what you do now is you solve for y. Okay, so you flip the x and y, okay, and then you solve for y. Okay, this is the step in order to find the inverse function. So let's do that real quick. 2y is equal to x minus 1, and then I'm going to divide everything by 2. So y is equal to 1/2 x minus 1/2. So this is the inverse function. So if my function was this, I would use the notation f of negative 1x is equal to 1/2 x minus 1/2. That's my inverse, okay? So again, I'm going very quick. This is meant to be like a power review, just like your teacher would give you. I'm going to erase this here. Now, one of the things you need to know by definition, an inverse function also is defined this way. F of the inverse composite function is also, here, let me just write it out because it is pretty confusing when you first see it. So you're like, what is that? This looks crazy. Well, it is kind of a crazy notation, but in mathematics, you shouldn't be too intimidated with this stuff. Once you understand it, you're like, oh, it's not that bad. So you remember those composite function things we were doing? Let me see if I still have it up here. This right here. Remember this composite function stuff? Well, we're going to be using composite functions here. Basically, it says if I plug in the inverse function, this guy, into here, I'm going to get x as a result. if you have the function and its inverse. If you actually have the function and an inverse, when I plug in the inverse function inside the function, I'll get x. And if I plug the function inside the inverse, okay, if I'll plug the function out inside the inverse function, remember the first time I plugged the inverse function inside the function, I'm going to get x. If I flip it around, I plug the function inside the inverse function, I also get x. So you may be asked to verify functions in that manner, okay? Really critical that you understand that. Again, a lot of you, your heads might be spinning, you're like, oh, this is just too much. Well, this is why you got to pay attention, in class and really concentrate on this material. But don't get stressed out. If you're lost, right now, take a deep breath and just start, correcting things. But within a short period of time, you can really bolster your understanding. And if you have a test coming up in a couple days, or maybe even tomorrow, if you're watching this video, you can still do a lot in order to do decent on your test. Maybe even get, an A. It's really going to be up to you and how hard you want to work. All right, let's talk about our next one here. Okay, when you can see at the last one here, special functions. I'll talk about that in a second. Is graphing functions. Let's talk about this real quick. I'm not going to spend much time on graphing functions, but again, it's something that you need to know. So let's take a function like f of x equals x squared. Now, if you've studied quadratic equations or parabolas, remember f of x is equal to y. So this is the graph of a quadratic equation. This would be the graph of a quadratic function. Okay, they still have the same graph, but let me just draw it. Okay, this would be a basic parabola. Go through the origin, something like this. Okay, so one of the things that you need to know, and when we're dealing with functions, is the effect on a function and how it affects the graph when we mess around with the function itself. Let me give you a specific example. So let's take our f of x equals x squared, and let's add 2 to it. What happens there? Well, when you add outside of this core function part, that just shifts the graph up or down. Okay, this is a vertical shift. So just move this parabola up 2. Okay, you need to understand what's going to happen. Okay, it's just going to move it up 2. If I had this as -2, it would move it down 2. Okay. Also, you need to know what happens if I add or subtract a number inside of this function part where the variable's at. Okay, so here this is going to be a left and right shift. Okay, we need to know that as well. So x minus 1, so we have to know, is this going to shift right or left? Okay, well, in fact, this is going to shift right. Students confuse this. You just think about what value, what value here will cause this to be 0. That's going to be 1. So it's shifted the graph to the right. So let me just put it in here. I'm going kind of quick because again, these are complete lessons in and of themselves. I'm just giving you a general idea. Okay, let's do one other translation. This is called function translations or shifts of functions, etc. So one other thing we'll have to be aware of. Let's go back to our regular f of x equals x squared function. Is if I have, let's say I put a 4x squared. If I put a number in front of that, what would happen? Well, there it would make the graph skinnier. Okay, that parabola skinnier. And then lastly, if I put a negative value in front of the x squared, it actually flips it upside down. Okay, so you can have a function. You'll be given a regular function, and then you'll be told to graph, the effect of all these different shifts that go on. Okay, these translations. You need to know that. Okay, let's wrap it up with special functions. So definitely not going to get into this pretty heavily because, again, a lot of things going on here. But one of the ones you for sure need to know is a compound function. So it would look something like this, maybe. 2x, x minus 1, and maybe x squared. So you'll have a function with a bracket, and you'll be like, okay, what does this mean? Well, let's say let me just write something out here. X is, okay, I think I did this right. I'm just kind of doing these examples on the fly. Okay, so generally these are referred to as compound functions. Let's see here, or piecewise functions as well. So when you come across something like this, what this means is you're going to use these function rules here, various function rules, depending on the value that you want to plug into the function. So if I want to find f of -8, okay, I have 3 rules I can choose from. Okay, however, the rule that I need to use, okay, because I'm trying to plug in -8, I have to look at where is -8 in terms of these particular inequalities. So -8 is a number less than 4, okay? So because -8 is a number less than 4, I use this rule, okay? So therefore, f of -8 will be 2 times -8, or -16, okay? If I wanted to find what f of 20 is, I would say, okay, where's 20 at here? Well, 20 is a number greater than 10, so it would be 20 squared, okay? If I wanted to find f of 6, 6 is between 4 and 10, so I would use this rule here, okay? So that would be 6 minus 1. That's an example of a special function that you definitely need to know. A couple other quick examples is the greatest integer value, okay, or step functions. They kind of look like this. All right, so if you're kind of familiar with that, I'm not even going to get into this because this is a whole other topic, but these are special functions that you could definitely see. And also recursive functions as well. Sometimes it depends on recursive functions. You might see a few examples in step functions. There's definitely, I would probably put a little more heavier emphasis on the special or the piecewise compound functions, but recursive and step functions are a part of that as well. And then there's just other type of functions, depending on how your teachers do in their particular class or what they want to emphasize. So lots to cover, lots to cover. Let's go and wrap this up. Again, if you made it through the end of this video and you're just like feeling overwhelmed, try to relax. At least you'll know. You can kind of like, you definitely learned something, I hope. So that's good. But now you know what you need to go and review, and that's really what I was trying to come across. So hope you consider becoming a subscriber. If you do, make sure you hit that bell notification. Again, on my channel, I have a lot of other specific videos on functions that will help you out. If you enjoyed this video, if it helped you out, I'd certainly appreciate a thumbs up, and leave me some feedback. Let me know how this video helped you, or maybe what you thought that I could have added. Again, functions is a huge topic, and I'm leaving things out. That's why I said these are the top 5 main things that you need to know. If you understand these 5 things, like in any functions test, I just can't see you not getting anything less than like a 90% if you really have a mastery on this. So with that being said, I definitely appreciate your time, and I wish you all the best. If you're taking an exam on that, remember, don't take anything to chance. You definitely have to study. And lastly, if you are interested in my full complete courses, I have complete chapter topics, notes, etc. on functions. You want to check out my Algebra or Algebra 2 classes. It'll probably be your best bet. But with that being said, have a great day.